There's a lot of activity when it comes to space weather here over the weekend into this week, and there's going to be some possible consequences that you're going to see the impacts of on your farm. Joining us to chat about it is Dr. Terry Griffin out of Kansas State University. Dr. Griffin, it's great to chat with you.
Thanks, Sean. I appreciate the opportunity to talk about space weather and agriculture.
Yeah, so we're gonna, when you and I saw each other back earlier in the spring in Kansas City, we chatted about space weather and some of these blankouts on GPS. What happened over the weekend?
So on Friday this week, we had a coronal mass ejection from a solar flare that was a M class solar flare, wasn't an X. X is the biggest solar flare. The M is one directly below that. It was moving really fast, and it got to us about a day earlier than we expected. CMEs are plasma; they're matter. They don't move at the speed of light, but they move really fast. And it got here sooner than we thought. So Friday night, Saturday morning, we thought this was going to happen on Monday and Tuesday, but it happened on Saturday and Sunday. But the sun is not done for the season. When I say season, we usually have about 3 years of solar max, and solar max to solar max is 11-year cycle. So we're in the last half of solar max, and this is where a lot of the activity occurs. My friends at Linker Space called it the battle zone. So right after the sunspot max occurs, we have less and less sunspots, but that's when most of the activity occurs. It's the battleground. And we see a lot of CMEs, coronal mass ejections, during that time. And these, when they get to Earth, they get the atmosphere really excited. The atmosphere and GPS signals from the satellites they get delayed, they get deflected through the atmosphere, making it more difficult to get a lock on location. And sometimes it's a complete lack of lock, but sometimes maybe even worse is that it gets a position calculation, but it's not correct, maybe off by 6 inches, a foot, 10 feet.
It can make a
And if
difference.
we're using RTK, and that's beyond our criteria.
Now, how long does this last for? If you are seeing impacts in your GPS,
Mhm.
like is this something that we just got to push through this week, and you may have to do some actual driving to get through the week, or what are the length of duration here?
A week would be really, really long. That would be under very severe
Okay.
conditions or multiple coronal mass ejections arriving at the same time, one after the other. So, for instance, the one that arrived on Friday, we had some disturbances on Saturday and Sunday. And each of those manifest into probably hours. So, if you think back last year, the weekend of May 10th, 2024, the Mother's Day weekend, we call it the Gannon storm. In Kansas, we had about 4 hours of outage that afternoon. And further north, North Dakota, Canada, it was much longer than that. And so it kind of depends on where we are. But a 4 hour outage was one of the first times that we've experienced this during times when we were using GPS. So we've had these types of things before in December, but we didn't really notice because we weren't out in the field at that time.
Can you can you predict the severity of the outages, or is it just a case of wait and see what the impact is for your farm?
It's kind of a wait and see. So we get a lot of questions about forecasting, and I usually use the idea of hurricanes in the southeast or tornadoes here in the Midwest. We know that every year we can expect tornado warnings and watches to occur in April and May. Whether or not they affect us individually is unknown until after the event. And the day of the tornado, we know we get warnings, we get watches if they are going to be in our area, but it's usually at the last minute. And same thing with the CMEs when they arrive. We can see the mass being ejected, and 8 minutes and 20 seconds later is when we see it. Okay, that's how long it takes light to get from the sun to the earth. But then the material moves really fast, and about 99% of the way here, we have some satellites in orbit. And that is our first indication if it's going to hit us. And it's 1 million miles away. And the sun is 93 million miles away, and our satellite's 1 million miles away. So it's 99% of the way here. before we get our first real insights if it's going to hit us or not.
Incredible. Those distances and just trying to understand how all this works is just absolutely fascinating. So what should farmers do?
So this week, we have some activity on the sun's surface happening, and this increases the probability of those things I just talked about, solar flares, coronal mass ejections. And I would keep my eye on the NOAA, the National Oceanic and Atmospheric Administration website. The shortest version of it is spaceweather.gov, and lots of good information there. Lots of complicated information for the average person, honestly. But it's really quick to scan it. There's three boxes I would refer people to. They begin with the letters R, S, and G. R and G are the most important. R is radio burst, radio blackouts from solar flares. G is geomagnetic disturbances. If those two have there's a number, G1, G2, G3, G4, G5. If it's G3, G4, G5, that would be an indication we may be having some atmospheric impact that would cause GPS to be less accurate. If it's G1 or G2, that means probably not so much, especially at the latitudes here in Kansas. Your listeners in Canada would be a little bit more sensitive because of closer to the poles. Or even the eastern seaboard of the United States, for whatever reason, they tend to be more sensitive to these things. And it's color coded. So G5 would be a dark red. If you see dark red, and you're having GPS problems, it's probably not something that you can fix locally. It's probably something global in the atmosphere. If the boxes are green or yellow, then you may actually have a local problem that you need to call your dealer about. But if they're dark red, there's nothing we can do about it other than not use GPS. And for automated guidance, some workarounds, but we have a lot of farms who are relying upon section control for planting and spraying that technology relies upon a good GPS signal.
Yeah, exactly. Like this is a time of the year with seeding and planting and that first application of in crop. Like we're told, like we are on the GPS. Like of course, like with a sprayer, if you have to drive, you can. But boy, it's a great reminder how beneficial GPS is to us when we don't have access to it or we can't rely on it in a week like this.
Yeah, and one of the funny things to me is that we become reliant upon this technology we created. It's almost humorous for the farmers who have not adopted GPS guidance. Last May were kind of, thought it was hilarious that the high tech folks couldn't get seed in the ground.
Yeah.
But because of GPS, our equipment's gotten bigger, wider, and sometimes we just decided not to put row markers on planters because hey, we don't need it. But fast forward to today, we got 48 row planters without row markers that may have a difficult time putting the seed in the ground.
Yeah. So obviously we're talking about some of the impacts in a week like this. Is this something, Terry, that could pop up numerous times through this year, or this is it for the year?
Definitely not. So a lot of folks thought last year on May 10th, 2024 was a once in a lifetime experience because, hey, it's never happened in my lifetime. Well, the reason was the previous solar cycle number 24, was very mild. The one before that, solar cycle 23, less than 5% of acres in North America had GPS on it. So GPS was not even really widely used then. This was our first time of having a normal solar maximum with GPS. And we're not having severe solar activity. This is normal solar activity if you look at what we've been recording for the last 200, 300 years.
Yeah.
And we're about halfway done with Solar Max. We're on the downhill side of the solar sunspot counts. But that means that this is when the most activity occurs, when we have the most geomagnetic disturbances. So my prediction on this is sort of like the tornado thing. Every 11 years, we should expect more activity, just like we expect activity with tornadoes in April, but this on an 11-year cycle. And for the next, let's say spring 2026, a year from now, we will be exiting the danger zone.
Mm.
And so we're going to be in it for the rest of 2025 and probably a good half of 2026. It's going to quiet down for 6 to 7 years, and then it's going to ramp back up again. And assuming we still use GPS satellites the way we do now, unless there's better technology that comes out in the next decade, we're going to have the same problem again after 2026.
Well, everybody stay on your toes out there. Of course, if there's an outage, you're going to know it. It's where it marks your location wrong that you're going to need to be paying a little bit more attention in terms of where you are in the field and on your passes. Dr. Griffin, thanks so much for joining us here today. Really appreciate it.
Thank you. It's good to be here.